Do you want to make cool graphs such as this one? Or graphs like this one to impress the judges and understand your robot better? Then you've come to the right place.
Hey guys, it's Team India and we are going to show you some cool features like logging and some other things which you can use to make your robot function better. So let's get straight into it.
Now that we are in the GitHub repo, you can download this or you can clone it using Git if you want. As I have downloaded this, I will unzip it and then open it using Android Studio. So to create a new code, you have to click on the team code, click on Java, and then you'll find this folder, right click, new, and then a new Java class. Now let's name it. Here, this is the normal Java class. Here you have to create two functions, which is public void init and public void loop. The init function is the function that runs when you initialize the code, and the loop function is the function that runs after the initialization phase, so when the robot is moving and all. So here I'll now go back to the main file and copy the logging code and explain it to you. So as you can see, this is a simple logging code. Now I'll just explain all the simple parts of it. Let me just remove this variable. So here I'll explain the first part, which is the string. This is the file path. Now to write this, you just string.format and you write the file where you want to save it, so which is first/data/ your file name. Then we just add a few suffixes, which is the environment and the absolute path. After this we have try block, so to catch any exceptions that might happen and then report them in telemetry. Here it's very simple, where we have just created a new writer using the writer library, and we have created a new buffer where there's an output stream writer, and in this we have the file output stream. Here we give the path of the file, then we set the append to true so that it does not overwrite the file every time we write a new value, instead it appends it. Then we give the encoding as UTF-8, then we write using writer.write command, and then in the brackets we give a string. Here I have just written something. After this we have the catch block, where if there's any problem, it shows it as an exception in telemetry using the error plus e.getMessage. So that's the simple explanation of the logging code. So here I'll explain all the code. Here we have defined the motors and a few variables, which I'll explain later. This is the normal code of the robot moving by our triggers and joystick, and this is the logic used. We have also used the current of the motor to get it. So for this we use the library called DC motor X, which is better than the DC motor normal library, which is given by FTC. This way the DC motor X gives more functionality. For example, we get current command, which can give us the current, where we have to specify the current unit. For our code we have used milliamps, but amps is also available. So now I'll come down here. As I said, this is the code of the robot moving. This is the code of the logging, so I'll just explain it. It checks if any of the motor has a power, so it's moving. Then it checks the times executed, which is a bit complicated, but I'll not get into it. It just checks the start time, which it gets the time. Now what is this time? So there's this function in this called elapsed time. To check the elapsed time, we start a new elapsed time. This starts at the initialization of the program. Now after initialization, when we first move the robot, it checks the time, so this way it also displays it in the telemetry. I'll get back to it. Now after this we have the average current, which is pretty self-explanatory, of both the motors, and also the times executed increment. We have the logging file. The only difference here is we have used the current of the motor and then a /n. This is to append it to a new line. We have made two files, one for the left and one for the right motors. After this, we have the robot stopping. So if any of the motors stop and this times executed function, it will set the times executed variable to -1 and the final time, which is the current time when the robot stops minus the start time. So this gives how long the robot has been running for. We put this in telemetry and then we can calculate what we want.
So, with our new code in hand, we rushed to see the capabilities of our drivetrain and which wheelbase would be the best. But when we tested everything and looked at the files, we realized that we couldn't understand anything because the data was given like this. So, we started thinking on how we could make it easier for us to understand. Then we came up with the idea of plotting it in a graph. So we made each drivetrain its own line and kept the y-axis as the current used and x-axis as time as per the control hub. And we made 3 such graphs. The first one was the normal moving speed of the robot. The second was the robot while it was pushing the hydrogen tank. And the third was the robot while it was turning.
Thank you all for watching till the end. We hope we were able to help you. We put the code that we used in the description down below. And if you have any questions, please feel free to ask in the comment section below. Thank you.